Okay, so here's the second main topic we're going to talk about, which is how does slope relate to the shape of a graph, and how can you relate the general shape of a graph with a description. But first, let's just talk about slope a little bit because this section goes into slope a lot. So first of all, the definition of slope is if you have a line, is the way we talked about it initially. If you take any 2 points on the line, maybe that point, and then you go from one point to the other one, how far over do you have to go? How much does your x coordinate have to change? That distance is called delta x. And then also, how much does your y coordinate have to change? If you're starting from this point and going down here, your y coordinate is getting smaller. And however much y gets smaller there, it's going to be a negative number represented by delta y. So when you divide this positive delta x and this negative number delta y, because x is increasing and y is decreasing here, you'll get a negative slope. And we've seen how with a line it comes out to the same thing no matter which 2 points you use. So even if you go from here to here, you'll still get the same result when you divide them. So that's one way you can think of slope, but you can also think of slope in terms of how much the y coordinate changes, how much y changes when x increases by 1. That amount that y changes is the slope. And you can see that here because if we just think of this as delta y over delta x, but the delta x is 1, well, anything divided by 1 is just delta y. So that's why this works. It's if you plug in delta x is 1, delta y just represents how much y changes. And if you have something that's not a line, you can still take 2 points on it and draw a little line between them. So here you could have a very small delta x and a larger delta y here. So in that case, if you have a larger delta y divided by a small delta x, you're going to get a large slope. But if you have points that are kind of like this, the delta y isn't that big, maybe the delta x is the same, that's going to be a smaller slope there, but still positive. But if you take points where this is happening, that will give you a negative slope. And I just want to show you a quick example I made where you can see the slope with changing with little triangles like this with this GeoGebra demo here. So what this is a random function that you don't actually have to know. It's actually y equals 2 times sine of x, but you don't even know what sine of x means because you haven't taken trigonometry yet, and that's okay. But anyways, if you take 2 points and look at this line between them, you can see how the triangle looks different, and this is set up so it's always 1 unit apart. The delta x is always 1 here. That's the horizontal side of that, is always 1. And so here, for example, if the delta x is 1, meaning x increases by 1, you can see that y decreases here. That's a negative change in y, so you get a negative 1.89 slope. And you can see as you move the 2 points around, keeping the delta x equal to 1, the slope changes. Here it's almost 0. It's really flat when you have something like that. But then you can see the slope is going to increase to give you big positive slopes over here. And then between points over here, it's getting close to 0 again. It's pretty small there. And then you get negative slopes again, bigger numbers for negative slopes there, like negative 1.9. And then it's going to get not as steep over there. So yeah, so if you have a curvy thing, the slope is going to change between different points. That's the moral of the story here. And that kind of relates to this next example exercise I'm going to have you do. Looks like that just barely fits. So Here are 3 stories about riding your bike to school. And various bad things happen. And which of the stories relates to the graph? This kind of has to do with slope. I want you to try it. You might get this wrong. It's totally okay to get it wrong because we haven't done anything quite like this before. So it's okay if you get it wrong. Also, you can see there's 3 stories but 4 graphs, so one of the graphs is left over. So let's write a story about that remaining graph. Here are my answers for A, B, and C. I'll write the story about graph number 2 in a moment. First, I just want to explain where I got this from, so you can understand in case you got something different. If you got the right answer, then you can just keep on moving on. You're actually done with this video if you got those right, but you might need to fast forward to check your answer for the missing graph. So first of all, the y-axis here represents distance from home. So starting here, when your x is 0 and your y is 0, that means you're just leaving home and your distance from home is 0. Then as time goes on, you move away, and then here you are like, wait, I forgot my book. So going back home means your distance from home is going to decrease. So whenever your distance from home is increasing, that's like this, that's going to go up from left to right. But as your distance from home decreases as time goes on, that will make your slope negative and make the graph be decreasing like this. And then this is the point when you are at home again, because again your y coordinate there is 0, so that's at home when your y coordinate is 0, meaning your distance from home is 0 at those points. And then you leave again and go to school. Okay, so that's that one. Things went fine until you have a flat tire. So while you're sitting there with a flat tire, your distance from home is going to stay the same while you fix it. Or while you call an Uber to pick up your bike and carry you and the bike to school. Whatever you do. There's going to be a while where it's staying the same. So this one with slope 0 means that you're not moving. The distance is not changing. And that means you're going to have slope equal to 0 at that point. So you're fixing your flat tire, and then maybe you fix it and you can keep going. Now C, this is where people get 1 and 2 mixed up, and that's what this next section is going to be all about. I started out calmly but sped up when I was going to be late. So let's think about why that's C here. If you take a straight line between 2 points like this here, that's going to have a smaller slope. Because it's not very steep there. But then if you take 2 points over here, it has a greater slope. And the greater slope means that you're going faster because there's a bigger change in your distance from home for the same change in time. So here this means you're going slowly because your distance isn't increasing that much. But here for the same amount of time you have a bigger increase in distance. So that means going faster. So what is the story for graph number 1? Well, what's happening here is you start out with steeper slope. Between these points, you have a greater slope, I should say. Oops. And so you're going a little bit faster in the beginning, and then it's not as steep later. That means you have less of a change in distance for the same amount of time. So one story for that could be something like this. I started going fast, but got tired and slowed down a little bit and kept going and got to school. All right, one more video after this, and it's going to be a tricky one.